welcome back to the deep dive. You know how sometimes, especially in tech fields, you get these terms that sound almost the same?
Oh, definitely. They can trip you up.
Exactly. And often, understanding the subtle differences is actually really key, especially when you're building something complex.
Mm-hmm.
So today, we're going to cut through some of that confusion. We're tackling two big ones in product development: design verification and design validation.
Crucial concepts.
Absolutely. Our mission here is to get clear on what they are, why they're different, and why getting that difference right is so important for success. Think of this as your shortcut to being really well informed on this.
Yeah, it's a topic that pops up everywhere, really.
Okay, let's unpack that.
Sounds good. And it's true.
Sure.
These terms, they show up constantly. And not just like in pure software dev.
Right.
Any field where you need precision, where user satisfaction really matters. Getting these definitions right, it's incredibly valuable. Helps avoid some costly mistakes down the line.
For sure. So to really wrap our heads around the distinction, let's define them properly. Let's start with design validation. What's that all about?
Okay, validation. Think of it as the reality check with the end user.
The reality check, I like that.
Yeah. So design validation, it's the process where you evaluate the product, the actual product, to make sure it meets the specific requirements of the people using it, the end users, the stakeholders.
So it's customer focused.
Absolutely. Its main purpose is testing the software or whatever product it is after development. You put it in a realistic setting, the user's environment, and confirm it actually delivers on those user requirements.
Okay, so you're demonstrating what? Consistency? Completeness?
Exactly. Consistency and completeness, but specifically with respect to the user needs. This is where you actually build a version of the thing and check it against what the user originally asked for.
Right. So you're proving it satisfies those user needs documents.
Yeah.
And you need evidence, right?
Yeah.
You mentioned that.
Mm-hmm. Objective evidence. You need proof. So that could be like an image, a text file showing output, maybe an audio file if that's relevant, some tangible proof it works as the user expects.
And that involves actual testing, inspections?
Testing, inspection, analysis. It's a pretty thorough process.
Okay, so that's validation, outward-looking, user-focused. What about verification then? How does that differ?
Right. So if validation looks outward, verification looks inward. It's got a distinctly different focus.
Inward how?
Design verification is basically a method to confirm if the output of your design work, what you actually built or created, matches the input specifications you started with.
Okay. So checking against the plan.
Pretty much. It's examining the thing and providing evidence that it lines up with its own blueprint, its internal specs. The goal is simply ensuring that the design product is the same as what was specified.
You mentioned design input and design output there. Can you quickly break those down?
Sure. Design input is basically everything that forms the basis for the design. Think physical requirements, performance requirements, the detailed plan, the blueprint.
Got it. The specs?
Yeah. And then design output is the result. What comes out of each design phase and ultimately the final design effort. It's what you actually produce based on those inputs.
And that output becomes?
It forms the basis for the device master record, essentially the official record of the product's design.
Okay. I think I'm starting to see the shape of it.
Mm-hmm.
But here's where it gets really interesting, because this is where the common mix-ups happen, right? They both sound like quality checks.
They are. Both are absolutely about ensuring quality. But, like you said, they ask fundamentally different questions. And nailing that difference is the key.
So what are the questions?
Okay, this is probably the simplest way to put it. Design verification asks, did you design the product right?
Right, as in correctly,
Yeah.
according to the specs.
Exactly. Did you follow the blueprint? And design validation asks, did you design the right product?
The right product for the user, for the market.
Precisely. So verification is about making sure the actual design output matches the expected design output. It satisfies the specifications.
Internal check.
Right. While validation is about making sure the final design is actually what the user needs and expects. It meets the user need.
Okay, let me try an analogy. Say, building a house. Verification is checking the foundation is poured correctly, the wiring matches the electrical code, the walls are plumb, building it right according to the plans.
Perfect.
Validation is then asking the homeowner, is this the right house for you? Does the layout work for your family? Is it in the right location for your commute? Does it meet your actual lifestyle needs?
That's a fantastic analogy. It captures it perfectly. Verification is the builder checking their work against the blueprint. Validation is the homeowner confirming the house meets their life requirements.
Great. So that core distinction is clear. Are there other, maybe more technical differences in how they're done?
Oh yeah, definitely. We can dig into a few more. Think about testing levels. Verification usually happens at lower levels, like unit testing, checking individual code modules, or primary integration testing, making sure a few components work together as specified.
Smaller pieces.
Right. Validation tends to be higher level. Secondary or full integration testing, system level testing, looking at the whole product working together in a more complete way.
Makes sense.
Yeah.
What about the order? Does one come before the other?
Good question. Yes, the sequence matters. Generally, validation follows successful verification. You can sometimes do some validation activities during verification, maybe, but
Verification isn't enough on its own.
exactly. Design verification is not a substitute for design validation.
No.
You verify the build is right, then you validate the product is right.
Got it. Verify before validate.
Usually, yes. Then there are the conditions. Verification. Well, that can often be done under more controlled conditions. On an individual module, maybe in a lab setting, doesn't always have to be the real world. Validation, however, must be conducted under specified conditions that properly reflect the actual user environment or intended use. It needs that real-world context.
Right, because you're checking if it works for the user.
Yeah,
And their world isn't a lab.
precisely. And finally, techniques and results. Verification might use static techniques, more things like code reviews, inspections, formal analysis, alongside testing.
Yeah.
Validation often culminates in that final test report we talked about. Detailed results of the test performed under user conditions, which then gets reviewed, approved, signed off.
And becomes part of the official record.
Exactly. Stored for future reference, audits, you name it.
Okay, that really clarifies the differences. So let's get practical. What does this all mean for the steps involved? How do teams actually do verification?
Right, the design verification process. It's usually broken down into stages. First is identification and preparation. And this often happens sort of in parallel with developing the specifications themselves.
What?
Because you need to make sure your specifications are actually verifiable from the start. So you identify the best way to verify each spec, what you'll need to measure, resources, tools, facilities. You plan the verification approach. And that plan gets reviewed by the design team.
So planning the test while you plan the feature makes sense.
Exactly. Then comes planning itself, which isn't a one-off thing. It's a concurrent activity with the development teams throughout the project. As design inputs change, the verification plan gets updated. You define the scope, make test plans, identify milestones. It helps reduce project risk by thinking ahead.
Okay, planning's ongoing. Then you develop the text.
Yep, developing. Test case development happens alongside the software development lifecycle, whatever methodology you're using. You identify different test methods. Crucially, your design inputs, the specs, need to be unambiguous so you can test them.
Clear specs make for clear tests.
Couldn't say it better. And here's a key thing. You create traceability links.
Traceability.
Yeah. Links between each test case and the specific design input, the requirement it's supposed to be verifying.
So you can prove every requirement has a test.
Exactly. It ensures full coverage and that the output demonstrably meets the inputs. Huge for accountability.
Got it. So plan, develop, then execute.
Then execution. You run the tests according to the plan, stick to the procedures. If results are weird or you need to change something, it gets documented and approved. Issues found. Logged as defects.
Standard testing stuff.
Pretty much. And then you use that traceability again, creating a matrix, to show that everything in the plan was tested and what the pass-fail rate is.
And finally, report back.
Finally, reports. At the end of each phase, usually, the design verification report summarizes everything, what was tested, the results, issues found. And there's often a specific design verification traceability report linking requirements directly to the test results. Any failures, non-conformance, it's all documented and needs addressing. Then reviews, approvals, the whole deal.
Wow, okay. That's a pretty rigorous process for verification. So after all that, you move to the design validation process. How does that look? Is it as structured?
It can be, but the methods used in validation can be a bit more varied depending on the product.
Like what?
Well, sometimes you validate by comparing it with similar products or systems already out there doing a similar job. This is pretty common for, say, validating configuration changes on existing infrastructure or using standard designs.
So benchmarking against something known.
Kind of, yeah. Other times it's straightforward demonstration and inspection. You just show it meets the requirement or inspect it to confirm.
Okay.
You can also analyze the design, maybe using mathematical models or simulations, especially for complex systems where physical testing is hard or expensive initially. You simulate the user environment,
Virtual validation.
in a sense, but ultimately for most products, validation involves performing tests on the final design. Real tests that validate its ability to operate as the user needs it to, under those specified conditions we talked about.
So proving it works in the wild, basically.
Great. That's the goal. And just like verification, the key is documentation. The test plan, the execution, the result, everything needs to be documented and kept as part of the design records. Validation really becomes the collection of all these results.
And you mentioned if equivalent products are used.
Right. If you use something equivalent during validation testing, maybe a slightly different component, you have to document why it's equivalent, what the similarities and differences are. Transparency is key.
Okay, it all comes back to that objective evidence for the user's needs.
Exactly. Proving the design meets the user requirements.
Let's make this even more concrete. Can we use that waterproof watch example again to illustrate both?
Sure, the watch is a good one. So remember, the user requirement, what goes in the product requirement document might just be, the watch must be waterproof during swimming.
Simple user need. That's the right product part.
Correct. Now, the design specification, the internal blueprint, might get more technical. The watch should function even if the user swims for a prolonged time at a depth of up to, say, 50 meters.
Okay, more specific. That's the design right part.
So verification would test against that specification. Do we use the right seals? Is the casing engineered to withstand 50 meters? Are the components rated correctly? Did we build the watch right according to our own detailed plan?
Checking the internal build quality against the spec.
Yep. Then validation takes that finished watch, straps it on someone, and has them go swimming.
The actual user activity.
Exactly. Does it actually remain waterproof during prolonged swimming? Does it still work afterwards? It's testing directly against the original user need. The validation test results must confirm the watch meets that user requirement.
And if it doesn't, if it leaks during the swim test,
Then the validation fails. You've got a mismatch between the user need and the final product. You'd likely go back, maybe redesign something, re-verify that change, and then revalidate until it does satisfy the user's requirement for a swim-proof watch.
okay, that really drives it home. Verification checks the build against the plan. Validation checks the plan and the build against the user's actual need.
You got it. That's the core loop.
So we've gone deep into the definitions, the differences, the processes. What does this all mean? Let's bring it back to the listener. Why should you, listening now, care about this meticulous distinction? Especially if maybe you aren't a developer or engineer.
Yeah, that's the crucial question. Why does this matter? I think the biggest payoff is about building better things more efficiently. Understanding the separation helps you focus your efforts.
How so?
Well, by having both processes, you get continuous monitoring. You can check that the design is on track to meet user needs at every stage, not just at the end.
Catching problems earlier.
Exactly. Also, clarity on functionality. Validation specifically highlights any gap between how the thing actually works and how the user expects it to work. It forces that conversation.
Finds those misunderstandings.
And thinking longer term, future understanding. Documenting all this, especially the validation, means if you need to change or enhance the product later, everyone understands the original intent and functionality. It prevents breaking things accidentally.
That's huge for maintenance and evolution.
Absolutely. It leads to increased productivity, too. By catching issues in the right stage, specification issues during verification, user need issues during validation, you reduce rework. Development time shrinks, productivity goes up, you deliver what's expected faster.
Do things right the first time, or at least catch errors sooner.
Pretty much. The process also clarifies the method scope. It forces you to think about how you'll validate each requirement. And it ensures user-centric validation because you're using data that represents the final user needs.
And you capture any problem.
Explicitly, any difference between the final product and the user need documents must be captured during validation. It's not optional.
And if you change the design based on validation feedback.
Then you need revalidation. Changes trigger a recheck to make sure the fix works and didn't break something else related to user needs.
It's a cycle.
It is, and it all comes back to that objective proof. Documenting every single thing during validation provides that undeniable evidence that, yes, this design meets the user requirements we set out to achieve.
So at the end of the day, it's about building confidence. Confidence you built it right, and confidence you built the right thing.
That's a great way to summarize it. Confidence for the team, for the stakeholders, and ultimately for the user. This whole discussion raises an important question, I think, for you listening.
Uh,
How might this fundamental distinction between did you design the product right and did you design the right product? How might that apply outside of just making physical products or software? Think about your own work, your own field, maybe even decisions you make in daily life.
that's a really interesting thought to leave people with. It's that difference between process and purpose, isn't it?
Kind of, yeah. Are you just executing the steps correctly, or are you ensuring the steps lead to the right overall outcome, the intended goal?
Yeah. Whether you're, I don't know, planning a marketing campaign, organizing an event, writing a report, even maybe planning your career path.
Hmm.
Asking both questions seems crucial. Are we doing this task correctly, efficiently, following the plan? That's verification. And is this the right task? Is this plan going to achieve the actual goal we care about? That's validation.
Exactly. Applying that dual focus, that check against the specs and the check against the user need or ultimate goal, it feels like it could lead to much better outcomes pretty much anywhere.
A powerful lens to look through.
Yeah.
Well, that gives us all something to think about. Thanks for breaking that down so clearly.
My pleasure. It's a vital distinction to get right.